Right, hello everyone. Welcome back. So today we're going into the idea of well, I wouldn't say it's probably a new one to you, but it's more of an extra one, I suppose. So what we're going to have a look at today is the idea of the area of a triangle using coordinate geometry. Now, we need to kind of use a caveat here because sometimes when you're doing the area of a triangle coordinate geometry, you can just use, half the base by a height because, for example, let's do an XY axis. There's your X, there's your Y. And let's say the triangle is resting like that, where one of the sides is actually one of the axes. They're pretty easy to figure out because you can work out, the length, the base. Okay, work out the base. And because that coordinate is there, you can work out the height. So that's usually pretty easy to do. And the same thing happens usually, like, for example, let's say you have you can work it out. If you've got a solid shape, you can just divide it in two, and you can do it a couple of different ways. But what happens if you don't have that? What happens if the shape, for example, is like that? So there must be some way of doing it, as the man says. Okay? So I suppose the way of doing it is you kind of have to force the triangle to be what you want. So, for example, again, apologies for drawing it like this, but it's just to spitball the idea of it. Let's say you have a triangle and it's just float around up here somewhere in the first quadrant or the second quadrant. It wouldn't make a difference where it is. If you can force it, if you can map it such that one of the points doesn't make a difference which corner, but one of them gets anchored to the 0, 0 line, you can actually use a particular formula. That formula is as follows. Okay, the area will be half the absolute value of x1, y2 minus x2, y1. Now, again, these are all in the log table, so you don't have to worry about them. But what we're going to focus on today is how do we turn a three-cornered and three-coordinated pointed triangle into a two-cornered one, because that's what you're really doing. Look, there's only an x1, a y1, an x2, and a y2. There's no third set of coordinates, even though the triangle has three sides, because what you're doing is you're forcing, by pulling it down here to make it look like that, you're forcing one of the sets of points to be 0, 0. So you're only having to deal with the other two. Okay, so it's not the hardest thing in the world to do, but I will go through it with you. Okay, so here's an example of one, and again, don't worry about it. See it done, you'll love it. Okay, so let's say you have a triangle, and these are the three corners, the coordinates of the three corners. Let's say 4, 1. Now, in order to use this formula, we need to have only two coordinates. So pick one. Doesn't make a difference which one you pick. Pick the one on the left, pick the one on the right. It makes no difference. But what you do is you force one of them to be 0, 0. That's it. You just force it. That you are going to be 0, 0. It's as simple as that. Okay? But if you're forcing him to be 0, 0, you have to force the other ones to change accordingly. Remember this whole idea of balance in maths? That if you do something to one thing, you really have to force it on everything, or else you're just going to be off kilter with your equations. So if 2 had to become 0, then you negative 2 this. So 7 negative 2 gives you 5. If 4 becomes 0, then you negative 4. So 3 minus 4 is minus 1. Do the same thing again, you apply it across the range. Take a negative 2 and a negative 4. 4 negative 2 is going to be 2. 1 negative 4 is going to be negative 3. So now suddenly I have x1, y1, x2, y2, half the absolute value of x1 by y2 minus x2 by y1. Now you use your calculator, please. Okay, so that's half of the absolute value of negative 15, and that's going to be plus 2. It's going to be a negative 2 times a negative is a plus 2. So it's a half of negative 13. So the absolute value of negative 13 is just 13. So half of 13 is 6.5 square units. Oh, there you go. A bit of fun. So again, it's in the log tables. You know, you'll find them yourselves somewhere in the log tables. You should have your log tables. If not, Google it, you'll find it. Okay. Always good to visualize these. Write it on the page before you do the sum. So at least, because what'll happen is a lot of you will have it in your log tables. You'll be looking over at your log tables and looking back, looking over, and something might go missing. Your eye get caught to another number or something, and you get them mixed up or you do something wrong. Remember, like all formulas you'll find in your log table, if they come with a preordained symbol, that has to be included in the calculation on top of any other negatives that might occur. So important. So many people just force it to be something different when a lot of the times it isn't. Okay, so that's where we're going now. We're going to try a few of these and we see how we get on. And hopefully you'll love them as much as I do. And if we do like them, then we'll just move on to some tougher ones, because that's what it's all about. Okay. You can see where this can become fun. If this forms half of a quadrilateral, you can just get this and double, you know, that type of way, double the answer. But anyway, that's another thing. So we're going to try one. Well, I'm going to write it down. You're going to try it, and then I will do it for you once we kind of go. So we'll avoid the ones that are the easy ones with 0 zeros already in them. Okay. Yeah, let's do a nice one. Okay, let's do 2 and 3. B and -5 and 1, and 3 and 1. And that's ABC. There's the 3 sides, or 3 corners of a triangle with their coordinates. And the question is, can you find the area? Remember, we're going to write down the formula. Okay, so don't forget when you're writing down these formulas, it's really important to visualize them. X1, Y2 minus X2, Y1. Now, you know, I don't remember these formulas all the time. God, there's so many of them. Okay, but if you can find a mnemonic or something that helps you kind of work it out, then, you know, so be it. The one I use for this one is X1 in the first and X2 in the second, and then it's just the opposites of whatever you want with the Y's, you know, that type of thing. Anyway, I'm going to count to 3, pause, you try it, and then I'll go straight away and answer it once you've unpaused. 3, 2, 1, pause. And we're back. Okay, so I don't know which one you picked to, which one you picked to become 0, 0. Do you know what? For the fun of it, let's do the second one. You know, the temptation is to go with that one, but let's go with the second one. So he's going to become 0, 0. So the other ones had to change accordingly. So how did he become 0? He went from -5 to 0 by adding 5, and he went from 1 to 0 by subtracting 1. So let's do the same thing. Add 5, subtract 1. Add 5, subtract 1. Well, it's an easy one. This is 7 and 2, and this is an easy one. This is going to be 8 and 0. So these are my new points. So 7 and 2, 8 and 0, x1, y1, x2, y2. So that's a half of x1 by y2 minus x2 by y1. So that's a half of -16, but it's the absolute value, which is 8 square units. Excellent. Very well done. Okay. Very, very well done. Okay. So that's a nice one. Okay. I'm going to give you another one to try, and then we might move on to another trickier one. Okay. So again, let's give it another go. Yeah. Just for the fun of it, we're going to try this one. Let's say you have 0, 0, 2 and 1, and 3 and 4. And the question is, can you find the area of the triangle where they're the 3 coordinates of the vertices, and it's the corners? So again, write down your formula, x1, y2 minus x2, y1. And I'm going to count to 3. You pause, you try it. 3, 2, 1, go. And we're back. Okay. This was a fun one. I think we might explore this one for a second because I think there's some fun to be had with this one. Okay. So this one already comes preordained at 0, 0. So let's just go with what they've said. If that's 0, 0, then let's see what happens here. Okay. X1, Y1, X2, Y2. So what is it going to be? It's going to be half of 2 by 4 minus 3 by 1. So it's half of 8 minus 3. So it's half of 5. Absolute value of 5, which is 5 over 2. Now, just for the sake of argument, what would have happened if I hadn't known that rule, but I still knew I had to make one of them 0? I know you're saying make one of them 0, 0. It's already 0, 0. Let's just, for the fun of it, force him to be 0, 0 and see what happens. So just bear with me over here. I'm just going to rewrite the 3 of them here. So let's force him to be 0, 0. So what are we doing if we're forcing him to be 0, 0? We're taking away 2 and we're taking away 1. So take away 2, take away 1. 0 minus 2 is minus 2. 0 minus 1 is minus 1. Okay, and then what are we doing to him? Take away 2, take away 1. So 3 minus 2 is 1. 4 minus 1 is 3. Now, we still have a 0, 0. So that's x1, y1, x2, y2. Half x1, y2 minus x2, y1. So that's half. Minus 2 by 3 is minus 6 plus 1. Quelle surprise, that's minus 5, which is absolute value of minus 5 is 5 over 2. Same answer. Sorry now that got a bit crazy down in the corner, but I just want to have a bit of fun with it. No matter what you do, you're always going to get the right answer if you follow forcing one of them to be 0, 0. Even though that was 0, 0, I thought it'd be a nice bit of fun to actually do the other one as 0, 0. Okay. So, well, you're probably asking yourself, well, where does this get hard? I mean, I can't see where this gets hard. Does it get hard at all, at all, at all? Of course, it does get hard. Okay. So, let's have a look and see where it does get hard. Let's say A is equal to 8, 2. B is equal to minus 2, minus 6. And let's say C is equal to 6. They always use K, so I'll use K. The area is, let's see, we'll go with 24 and see what happens. Now, I'm not sure if this is going to work because I'm just making this one up out of my head. Find K. So this is where your kind of algebra is coming in. So we know everything apart from K, but we know it generates a 24. Okay, so let's just do what we know we need to do. Let's try and force one of them to be 0, and see where it leaves us in terms of what K has to be. So what do we know? We know that half of x1, y2 minus x2, y1, we know that sum has to be equal to 24. So let's fill it out. But first of all, we need to turn one of them into 0, 0. Okay? So I'll pick the first one. It's the easiest one to get to 0, 0. So 8 and 2, minus 2, minus 6, and 6 and K. So if he becomes 0, 0, that means I'm taking away 8, taking away 2. If I take away 8, I get negative 10. If I take away 2, I get negative 8. Take away 8, I get negative 2. And this is the tough one. Okay? If I take away 2, that's K minus 2. Tough one. You see that? So take away 8, take away 2. Take away 8, take away 2. So now let's put them into our formula and see what happens. x1, y1, x2, y2. So we have half of x1, y2 minus 10 by K minus 2 minus x2, y1. and it has to be equal to 24. Looks a bit messy, but it will come together like everything, okay? So minus 10k plus 20. Now, let's do this in pieces. Minus 2 by minus 8 is plus 16, minus 16. Okay, so what if you think about it, I need to have a 48 in here, don't I really? Because half of 48 is 24. So let's see what we get. Okay, minus 10k minus 4. Okay, sorry, that's a plus 4. Let's just double check that. Yes. Okay, now let's. I would suggest at this stage, depending on how comfortable you are, you could guess the answer, or you could multiply both sides by 2 to get rid of the half, which it's probably the easiest thing. Right. So it doesn't make a difference that there's a negative there. Okay. We just need to figure out a number now. So we've done this sum before in algebra, haven't you? Yes, you have. You square both sides, but we're not going to go down that route. Okay. So let's think about ourselves for a second. Okay. Minus 10 times something plus 4 gives you 48. So that's if I did minus 10 times 5, would it work? Minus 10 times 6, minus 10 times 7, minus 10 times 8. Okay, that's the kind of idea you're going to have to come across with this one. Okay, so what do you think it's going to be? I'm going to give you a pause and see, can you work it out yourself? Okay, right, here we go. So let's do the easiest one first. Okay, 44 plus 4 is 48. Okay, so minus 10k is equal to 44. K is going to be equal to minus 4.4. That's one possibility. Okay, so that is one possibility, and but that generates obviously a positive. You want that to be positive. There has to be another possibility. Okay, the other possibility, of course, is if it's negative. Okay, so if you had 52 there, 52 minus 52 plus 4 will give you 48 minus 48, and of course the absolute value of minus 48 is half. That's the kind of answer you'd be looking for there. Okay, so minus 10k is equal to minus 52. K is going to be equal to 5.2. So both those answers will work. Okay, they have to work. Okay, right. So I'm going to see if that makes sense to you. Hoping it does. Okay, they're a lot bit tougher. Ideally, if you're doing the sum, then you would do square both sides, you get a quadratic, and you solve the quadratic. Okay, I picked these ones out of my head. That's why they're giving me such awkward little answers. The reality is, if this was done in real time, they'd be nice little numbers that you could figure out yourself, either do it through inspection or through a very quick quadratic. Okay, so listen, I'm going to leave that there. I'm going to drop some homework tomorrow just as this drops. Best of luck with it. Again, this is all the kind of baby step stuff. This is none of the tough stuff yet. Any problems, you know where to email me. Okay, so give it your best shot. Thanks. Bye.